There's a number of codes related to oil pressure sensors and their circuits. In this video, I'm covering P0520 to 21, engine oil pressure sensor signal performance. The oil pressure sensor is a vital piece of an engine's management system. All engines require sufficient lubrication flowing through the engine crankcase and cylinder head to keep the moving components well lubricated. The oil pressure sensor's job is to let the engine control module, or ECM, know of any oil pressure loss. Some of the locations for the oil pressure sensor are on the engine crankcase, oil filter housing, or directly on the external oil pump. This is a typical schematic for a two-wire oil pressure sensor circuit. It consists of a low reference or ground from the ECM and a signal circuit connected to a pull-up resistor. The signal circuit voltage will be either 5 volts or 0 volts. Looking at the fault table, a P0520 or P0521 is caused by either a circuit malfunction or poor signal performance. This fault could be in the sensor, the module, or the wiring. Check the engine oil level and its condition, as these can cause performance issues. If you have a scan tool, you can check the live data to confirm the fault by looking at the sensor readings. Perform a wiggle test on the wiring harness that the oil pressure sensor is connected to, while checking the readings on a scan tool. If the readings change, the fault could be in the harness or the connector. Check for corrosion and any evidence of abrasions or damaged wires on the sensor. If this is all okay, move on to checking the signal circuit. Check battery voltage before testing the circuit. This is to give you a reference voltage for all of your readings. To start the diagnosis, set the multimeter to volts DC and set it to 2 decimal places. This will give you a much quicker reading. Disconnect the sensor from the harness and turn the ignition on. Always use the correct test connectors. I'll check the ground circuit first. To do this, connect the multimeter lead to the low reference terminal of the sensor harness connector and the other lead to battery positive. You should see battery voltage. If you don't have battery voltage, check for a shorter voltage. Move the lead from battery positive to battery negative. If you now have voltage, this will indicate a shorter voltage on the low reference line. Turn the ignition off and disconnect the ECM. Then turn the ignition back on and retest again. If the voltage is still present, there will be a shorter voltage in the harness. If the voltage is now gone, then it is either a shorter voltage on another wire from the ECM or the ECM itself. To test the harness, set the multimeter to ohms and check for continuity between the low reference terminal at the sensor harness connector and each terminal on the ECM connector. If there is no fault found here, the ECM will have an internal short to voltage. If there was no ground or no short to voltage, there could be an open in the low reference circuit, module connector, or the module itself. If this were the case, the next test step would be to go to the next connector in line and check the low reference circuit, then recheck your readings. In this case, it would be the ECM connector. While back probing the appropriate terminal, check for a ground. If there is a ground here, then the fault will be an open circuit between the ECM and the sensor harness connector. Perform a wiggle test on the harness while looking at the multimeter. If the readings change, repair that section of the harness. If there was still no ground, the fault would be in the ECM connector or the ECM itself. Disconnect the ECM connector. Check terminal tension and check for corrosion. If this is all okay, the fault will be in the ECM itself. Now that I've covered the low reference line, we can move on and test the 5 volt signal line to the ECM. With the ignition on, the reading should be between 4.8 to 5.2 volts. Set the multimeter to volts DC. Connect the positive lead to the signal line on the harness connector and the other lead to battery negative. If the voltage is correct, the most likely cause is the sensor itself. This can be confirmed by connecting a fuse jumper between the 2 sensor terminals whilst observing the scan tool readings. If the parameter changes, then the sensor is the fault. If the parameter didn't change, or there was more than 5 volts on the signal wire, then it is possibly a short voltage. Turn the ignition off and disconnect the ECM. Turn the ignition back on and retest again. If the voltage is still there will be a shorter voltage in the harness. If the voltage is now gone, it's either a shorter voltage on another wire from the ECM or the ECM itself. To test the harness, set the multimeter to ohms and check for continuity between the signal terminal at the sensor harness connector and each terminal on the ECM connector. If there is no fault found here, the ECM will have an internal shorter voltage. If you had no voltage on the signal wire at the sensor harness connector, move to the next connector in line, which in this case is the ECM connector. Back probe the ECM and with the ignition on, check for 5 volts. Perform a wiggle test on the harness and see if the readings change. If there is 5 volts here, there will be an open circuit between the ECM and the sensor harness connector. If there was no 5 volts, the fault will be the ECM connector or the ECM itself. To test the ECM connector, check for terminal tension and corrosion. If nothing is found, the fault will be in the ECM. That's the diagnosis of P0520 to 21. I've shown you the steps to find the possible faults that can cause these DTCs. Understanding how the sensor works will help with diagnosis. And remember, keeping up to date with technology is essential in today's automotive industry. Thanks for watching and bye for now.